So in last class we were discussing problems on Fourier series, and I also gave you few examples. Now I will take that discussion forward, and a problem we will do, and that problem is this. Fx is equal to x mod x, and this is from -1 to +1. Okay, this is the question. Fx is equal to x mod x. This is odd function, this is even function. So what is the multiplication?
Odd, sir.
Odd. And limit is this. So what is the value of L? The value of L is 1. Correct? The value of L is 1. And if I want to write this, so fx is odd function. So immediate consequence is that an will be equal to 0. Okay? So if I write fx is equal to, it will become summation n is equal to 1 to infinity bn sine of n pi x by L. This will be the value of the series. And what will be the value of bn? Tell me. 1 by
1/2.
1 by L, and integral minus L to L
X mod X.
x mod x, that means fx sine of
N pi x.
n pi x dx. Correct? So now this is odd and this is also odd. So multiplication is even this time. So this will become 0 to 1 2 times x square sine of n pi x and dx. Please see this. Is this okay?
Yes, sir.
This is value of bn. And now integrate this. So it will become first function integration of second. Sine का क्या होगा? Minus cos n pi x over n pi minus derivative of this, integration of this, and plus derivative of this into integration of this. So again integration of sine will be minus cos. So it will be cos n pi x over n cube pi cube. This will be the integration. एक बार check कर लो. So bn will be 2 times. So now see limit is 0 to 1. So this term will be 0 at 0 and 1 पे भी 0 होगा. So this will not be taken care. And let us check this term. Upper limit minus lower limit. So upper limit will be minus cos of n pi over n pi. And lower limit will be 0 because of x. And plus 2 times, let us put this also as upper limit minus lower limit. So it will become 2 by n cube pi cube. Upper limit is 1. So minus 1 to the power n minus 1. So this is the value of bn. And this will also become minus 1 to the power n. Every step is clear? So this is the value of, so can we write few terms? For example, what will be b1 from this? What will be the value of b1? So this will become 1 by pi if you put n is equal to 1, and plus 2 by pi cube. N is equal to 1 will give this minus 2. So it will become 1 by pi minus 4 by pi cube. देखना सही है?
Yes, sir.
This is b1. And what is the value of
Sir,
b2?
into 2 भी तो
सर
आएगा.
2 रहेगा ना पूरे
हाँ,
के मल्टीप्लाई
2 बाहर है. 2 is outside. So let us multiply this all by 2. So multiply this by 2. So we can write as na 2 here and 8 here. And what about v2? So जैसे 2 रखोगे ये 0 हो जाएगा. And this will become 1. So it will become 2 into
minus 1 by 2 pi.
minus 1 by 2 pi. So 2 and 2 cancel, it will become minus 1 by pi. So in this way we can calculate different coefficients. The main part is this, if you can handle it quickly. And this also by using the property we have. So जब select करना होता है तो बड़े आराम से select हो जाता है, because an is 0 और किसी option में अगर an दिया है, that means that will not be the series ना. Got it? So let us take another question. और इस बार I will write the complete objective type so that I will tell you how to select. Okay, so let me draw this. Suppose this is the function these are parallel lines, okay, and this is some t and this is some x of t, okay, and we have to write Fourier series. So options are, this is 2 by t, 2 by pi, cos of pi t by t minus 1 by 2, cos of 4 pi t by t plus dash dash dash, b 2 by pi minus sine pi t, half of sine 2 pi t by t dash dash dash, c is 2 by pi sine of pi t by t minus half sine of 2 pi t by t plus dash dash dash, and d, it is 2 by pi minus cos 2 pi t by t plus half cos of 4 pi t by t minus dash dash dash. So these are the options. चलो जल्दी से थोड़ा ट्राई करो. it should be 2 by t here ना. जब ये t में लिखा हुआ है तो ये पाई तो आएगा नहीं ना कभी. करेक्ट. जो फॉर्मूला होता है उसमें क्या होता है? कोफिशिएंट्स. सो व्हाट टाइप ऑफ फंक्शन, पहले कोई पीरियड बता सकता है इसका? व्हाट इज द पीरियड?
minus t to t.
नो.
Minus t by 2
minus
t by 2.
1, sir. 2t. 2t. It's sir.
So this is minus t by 2 and this is t by 2. Correct? And this thing is repeating. So this is that building block. बात समझ आ रही है? So this function xt is actually equal to what? What is the equation? What is the slope? So slope is perpendicular 1 upon this base. So it will become 2 by t. Correct? So it will become 2 by t into t. Correct? So this is the equation and it is between minus t by 2 to t by 2. So this is the question actually. So यहाँ पे t लिखा हुआ है, इसका मतलब ये नहीं कि यही है, ये तो उसी लिए लिखा है कि आप वो गलती कर दो जो आपने कर भी दी. बात समझ आ रही है? So what is p here? It is t. And what is the value of L? What is L? T by 2.
T by 2.
And you can see this is odd function. Yes or no?
Yes,
So
yes.
Yes.
option A and option D, ये तो सीधा गलत हो गए. Correct? Because being odd function, what will happen? The value of xt will be 1 by L, that means 2 by t, and summation n is equal to 1 to infinity bn sine n pi t by L. This will be the series. ये देखो जरा ध्यान से, अगर नहीं समझ आ रहा है तो you can ask. This is very good question to understand. Are you understanding this?
Yes, sir.
So if you see this, these two options are gone because there will be no cos. And one thing also we can see that from this value and this value, please see this. If I take the value little greater than 0, देखना ध्यान से. If we take value little greater than 0, then suppose I take the value little greater than 0 somewhere here. Okay, so this value should come negative or positive?
Positive. Positive.
Because this is this भाई function की value तो exist करती ही है ना. The value of function should exist. So the first term should be positive. So in that way आप ये भी देख सकते हो कि इन ऑप्शन से बगैर किए भी आप कह सकते हो कि this C will be the answer, but otherwise you can calculate from there. Okay, so this coefficient Bn can be calculated, but otherwise you can directly write also by just seeing that which one. जो मैंने आपको बताया था ना कि भाई जैसे 0 पे 0 हो रहा है तो दोनों हो रहे हैं, लेकिन सपोज मैं 0 से थोड़ी बड़ी वैल्यू लूं कहीं यहाँ पे, if I take some value here, तो what should be the value? या फिर यहाँ पे देखो t by 2 है जैसे सपोज, एंड t by 2 से थोड़ी ज्यादा वैल्यू लूं तो मेरा आंसर नेगेटिव आना चाहिए. करेक्ट? इफ आई टेक वैल्यू ग्रेटर देन दैट, तो इस तरीके से भी आप चेक कर सकते हो कि विच वन. अदरवाइज यू कैन कैलकुलेट फ्रॉम हियर डायरेक्टली bn. Bn you can calculate from the series. What will be the value of Bn, by the way?
सर xt में 2/t नहीं आएगा ना xt
आफ्टर B1 कैलकुलेशन लिखा
अरे
जाएगा।
ये मैंने पहले ही लिख दिया, सॉरी। यहाँ से Bn की कैलकुलेशन में आएगा। Bn विल बी इक्वल टू, वैसे कर लेता हूँ, मान लो मुझे कुछ याद नहीं है, तो आई विल डू इट लाइक दिस, xt इंटू साइन 2n pi t by t is equal to Bn into sine square 2n pi t by t, correct? And then integrating it from कहाँ से कहाँ, minus t by 2 to t by 2 dt, and this also from minus t by 2 to t by 2 and dt. Okay, so this side what will be the value? 2 times Bn t by 2 t by 4 t by 4, so it will become Bn into t by 2, correct? So what will be the value of Bn now? So Bn will be equal to 2 by t into integral, so this is also odd, so I can write 4, so it will become 4 by t integral 0 to t by 2, the value of the function, which is 2 by t into t, and then sine of 2n pi t by t and dt. So this will become the coefficient, and that you can just integrate. You know how to integrate it, okay? So before solving something, or you know, हाँ,
सर ये जो ऑप्शन है ना इसमें 2/पाई आ रहा है, टी नहीं आ रहा
2/पाई आ रहा है
जी।
अभी जो मेरा t आया था वो कट जाता है क्या फिर?
हाँ सर, टी स्क्वायर ऊपर नीचे मिल जाते हैं।
सर कट जा रहा है वो।
अच्छा, फिर वो लिख लो यार जो पहले मैंने लिखा था, 2/पाई ही लिख लो फिर सब में, ठीक है? मुझे लगा कि देख के कि शायद t बचेगा तो मैंने t कर दिया था।
ओके सर।
तो मैं ऑप्शन लिख देता हूँ दोबारा, जस्ट टेक ऑप्शन दैट xt इज इक्वल टू 2/पाई एंड साइन से शुरू होगा, ठीक है ना? साइन ऑफ दिस, ऐसे करके। और भी किसी ने किया? किसी और ने भी किया भाई? नहीं। There is a function fx in the domain -1 to 1, and the function is given by this, something like this. This is 1, this is 2/3, this is -1, this is 1, this is x, and the function was written like fx is equal to a0 plus a1 cos pi x by 2 plus a2 sin pi x by 2. And what are the values of a0, a1 and a2? This is the question. Okay, so what type of question is this? किस टॉपिक का क्वेश्चन है, बता सकता है कोई भाई? You have to write the values of a0, a1 and a2. this is a question that ये parabolic सा है, okay? This is kind of parabolic like this. This was fx and somebody approximated this function as this. कोई नाम नहीं लिया गया, लेकिन ये किसका क्वेश्चन है, किस टॉपिक का?
Fourier series.
This is Fourier because the function is approximated in the form of sine and cosine.
Cosine.
Correct? So now, how we will write the values of a0, a1 and a2? The first thing is that at x is equal to 0, the value of function should be 0 or not? Here. Bolo bhai.
Yes, sir.
So 0 is equal to and also a2 should be equal to 0. आप agree करते हो?
Yes, sir.
Yes, sir.
Why? Because this like symmetric about y-axis. This function is like symmetric about y-axis. So this is even function. So a2 should not exist. Correct? So my series became this. ये बन गई. And at x is equal to 0. So 0 is equal to a0 plus a1. This is 1. So what is value of a0? It is minus a1. एक बार देखो जरा ध्यान से.
Yes, sir.
Correct? So a0 is equal to minus a1. So what will be my series now? a0 minus a0 cos pi by pi x by 2. Yes? Now this is the series. And now at x is equal to 1, the value is 2 by 3. So that also I can use. The value is 2 by 3 at x is equal to 1. So when I write 1, what will happen? The value of a0 will come out to be 2 by 3. बोलो भाई. So values आ गई सारी. 2 by 3. इसकी
minus
Minus 2 by 3.
और इसकी.
0.
So these are the values. If you have any question, you can ask.
सर ये यहाँ पे जो एफ ऑफ एक्स की वैल्यू हम लोग 2/3 कंसिडर किए हैं मतलब फिगर से तो वहाँ पे a0 माइनस a0 cos पाई x by 2 वहाँ पे x की जगह फिर हमने यहाँ पे क्या पुट किया है?
आप बताओ क्या पुट करेंगे? ऐसे अपनी मर्जी से तो कर नहीं सकते.
नहीं.
क्या पुट करेंगे x की जगह?
0.
fx 2/3 कब है?
जब x की वैल्यू 0 है.
तो आपको ग्राफ बहुत अच्छा पढ़ रहे हो आप.
Equal to 1.
सॉरी 1 है.
ये चीज पढ़ना तो थोड़ा देख लो भाई. ये चीज पढ़ना तो आपको आना चाहिए ना कि at x is equal to 1, what is the value of fx? मान लो कोई ग्राफ है ऐसे 1 पे इसकी वैल्यू है सपोज 2/3. तो ये वैल्यू 0 पे है या 1 पे है? What is the value of this function at 0? बताइए बताइए जल्दी.
ऐसे 0 पे 0 है
0
1 पे उसका वैल्यू 2/3 है.
ओके.
a0 minus a0 2/3. So then a0 equal to 2/3 कैसे है?
Sorry, a0?
a0 minus a0 equal to 2/3 sir. Then a0 equal to 2/3 कैसे है?
This step.
Yes sir.
This is very high standard mathematics. Which cannot be solved so easily. अरे भाई a0 into 0 क्या होगा? So
Okay,
should I write this also? a0 minus 0.
No, I understand sir. 0 I will not consider.
So cos pi you put x is equal to 1. So cos pi by 2 will be what? That will be equal to 0. Anyways. So अब ऐसा नहीं कि आप फूरियर सीरीज कर रहे हो तो आप बेसिक अलजेब्रा, बेसिक मैथमेटिक्स, बेसिक ट्रिग्नोमेट्री भूल जाओ. You have to keep that every time with you. आपने देखा कैसा क्वेश्चन फूरियर सीरीज पे, मतलब बिल्कुल सिंपल है, बट अब आपको थोड़ा सा तो जनरलाइज वे में देखना होगा कि this is a question from Fourier series. Okay, now one thing more I wanted to discuss with you, and that formula is known as Parseval's formula. Parseval's formula. Okay, so what is this? What is Parseval's identity or Parseval's formula? So suppose fx is a function, is a series a naught plus uh, summation n is equal to 1 to infinity an cos nx plus bn sin nx. Okay, suppose this is the infinite series, then the Parseval's identity says that 2a naught square plus summation n is equal to 1 to infinity an square plus bn square is equal to 1 by pi integral fx square dx minus pi to pi. This is the Parseval's identity or Parseval's formula. So please see this, you can apply to any of the questions we have done. If fx is odd, then what will happen this side? This a naught and an will not be there. Only b1 is. So in general, it is like this: 2a naught square plus a1 square plus a2 square plus dash dash plus b1 square plus b2 square plus dash dash is equal to this. So whenever you see in the options squares of your coefficients, some relation between the squares of your coefficient, then you can apply this Parseval's identity. Correct? So कोई भी क्वेश्चन ले सकते हो जिसमें मैंने fx is equal to निकाला हुआ है, and this side just take square of that. So suppose मैं एक ले ही लेता हूँ. Suppose I take a very simple function fx is equal to x between this minus pi to pi. Okay, so I apply this Parseval's, so this will not be there. So just b1 square plus b2 square, I mean just summation n is equal to 1 to infinity b1 bn square will be equal to this side 1 by pi integral minus pi to pi and x square dx. देखो जरा, correct? Yes or no? And this will become 1 by pi and क्या हो जाएगा? 2 by pi. 2 by pi, it will become 0 to pi, and this will be pi cube by 3. So pi cube by 3. So this will become 2 pi square by 3. Please see this. Otherwise this question will look very very tough कि कैसे squares coefficient का square देखें. So जहां भी coefficient का squares आ जाए वहां पे you can use this Parseval's identity or Parseval's formula. Is that okay? देखो जरा ध्यान से, कोई डाउट है तो बताओ. Can I erase this भाई?
Yes, sir.
So इसको मत भूलना, Parseval's formula. Any question you can apply. Just you can see there, it is fx square. So in any question you can apply. One more question. You have to write the Fourier series for 0, x and 1, and the function is given as fx is equal to summation n is equal to minus infinity to plus infinity delta x minus n, where n is integer. N is an integer and you are given with different options. Like one of the options is 1 plus 2 cos 2 pi x plus 2 cos 4 pi x plus dash dash dash, like this. Okay, so what is the value of L here? तो पहले ध्यान से देखना, it is full series, so we have to write it because it is not given to write half series, so I will take it full series. So 2L is equal to 1. So what is L? L is 1 by 2. Correct? And this is symmetric. So let us plot this. इसको plot करो n की अलग अलग values के लिए from minus, so n is equal to 0 भी आएगा ना? So that means delta function will be here, 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 like that, and here, here, like that. So this is 0, this is 1, this is 2, this is minus 1, this is minus 2. These are the locations of the delta function. Correct? So this is fx. I mean, just you don't know what is this delta of x minus x naught.
f equal to x naught पर
हम्म,
डेल्टा फंक्शन मैक्सिमम
तो मतलब नहीं, मैक्सिमम कुछ नहीं होता इसमें, एक ही वैल्यू होती है बस.
सिंगल
It is present at x naught and absent at all other points. Okay, this is the meaning of delta function. And also if you take integral, so अब ये फूरियर का सवाल बता रहे हैं, अब यहाँ डेल्टा फंक्शन बताना पड़ रहा है. चलो कोई बात नहीं. So the properties is like this: minus infinity to plus infinity delta x minus x naught dx is 1. Its area under the delta function is always 1. And also if I take minus infinity to plus infinity fx delta x minus x naught dx, that is equal to fx naught. These two properties are very important. This you should know. Okay, how many of you know this? आप लोगों को ये दोनों properties पता है या नहीं? A and B.
Yes.
यस सर पता
No,
है
sir.
So, इतना पता होना चाहिए इस सवाल करने के लिए.
यस सर
So इसमें देखो n की सारी वैल्यूज के लिए मुझे सारे बनाने पड़े because summation है ना. So all of them. So the first step is let us calculate the, so इस तरीके से options थे, तो मैंने सोचा कि option को ऐसे कर लेता हूँ कि I will calculate the fixed values. Let me quickly write the all options so that you will understand what I'm talking about. So option B is 1 plus cos pi x. Option C is cos pi x. And option D is cos pi x plus sin pi x plus, like this. Okay, so this is even function or odd function? Even. So this will be, sin नहीं आ सकता. Correct? Now please see, in this case अगर ये आंसर है तो a naught should be 0 ना, the DC term free from x. और अगर ये आंसर है या ये आंसर है, if these are the answers, so you can see we have to only calculate a naught to get two right answer. And this is what, a1. Correct? A naught and a1 if I can calculate, I will get the right answer because here a1 is 1 and here a1 is 0. Can you see that or not? Tell me.
Yes, sir.
यस सर
Yes, sir.
So let us write the value of a naught. So suppose my series is this. What will be my series? Fx is equal to a naught by 2 you want to write or not? Whatever, if you want to write this, plus summation n is equal to 1 to infinity an cos n pi x by L. And L is what? 1 by, correct?
Sir, इस केस में फंक्शन इवन कैसे है?
Symmetric about y axis. जैसा y axis के right है वैसा ही y axis के left है. So this will become 2n pi x ना, cos 2n pi x So let us calculate. What will be the value of a naught? क्या होगा? 1 by L. Yes. Integral 0 to 1, 0 to L, and fx, which is summation n is equal to minus infinity to plus infinity delta x minus n and dx. Please see this. Now अगर आप ध्यान से देखो तो इस डेल्टा फंक्शन में ये जो वैल्यूज हैं सिर्फ एक वैल्यू ही इसके रेंज के बीच में आएगी. देखो ध्यान से. दिस इज 0, दिस इज 1. It is like this, na? 0, 1 and minus 1. So from 0 to 1 I want to go from here to here. So it will become 2 ऊपर आ जाएगा ना. And what about here? What you will get here? बताओ भाई. The limit here is from 0 to 1. So what we will get? As this integration, what we will get? You can keep this summation outside and just take the integration.
One, sir.
So 1 we will get, and what will be the value of first term now? A naught by 2. A naught by 2 की वैल्यू क्या होगी? 1. So please see here. ये भी हो सकता है और ये भी हो सकता है. अब जरा दूसरी वैल्यू ऐसे ही कैलकुलेट करो जल्दी से. Calculate the next value. That is A1. So if you calculate A1, what you will get? It will be 1 by L integration 0 to L fx and delta x minus n and cos 2n by x and dx. This you will do.
सर लिमिट 0 to 1 क्यों ले रहे हैं?
क्योंकि 0 to 1 given है.
बट L तो 1 by 2 है ना.
तो L 1 by 2 है. तो अगर तुम फुल सीरीज लिखोगे, if you are writing the full series, then it will become 0 to 2L, ना? What is full series? It is minus L to L or
0 to 2L.
0 to 2L. So this question can be done in two different ways. अगर मैं कह दूं half series, तो you will take L is equal to 1. Correct? If अगर मैं कह दूं कि इसकी even series लिखो, half series जो पढ़ाया था, तो उसमें क्या होता है? 0 to L होता है. But full series is either minus L to L or 0 to 2L. Okay? So in this way, again this will you will put this integration as x is equal to 0 अगर आप put करते हो, x minus n है. So again you will put x is equal to, so ये वैल्यू कब आएगी डेल्टा फंक्शन की वैल्यू? Again this inside will be 1 and this a1 will be 2. So you will get this and यहाँ तो 2 pi x था ही, सीरीज में ही आ गया था वो, तो देख लो, it was in the series. So answer A is correct. Okay, so यहाँ पे प्रॉब्लम फुरियर सीरीज की नहीं है, प्रॉब्लम है दिस डेल्टा फंक्शन. और दिस आई विल टीच अगेन. डेल्टा फंक्शन एक्चुअली मैं थोड़ा सा बता देता हूँ आपको. जस्ट गिव मी लिटिल टाइम. होता क्या है कि suppose you consider a function like this. You consider a function like this in which this is b and this is a. So what is its area? A into b, correct? And let this is equal to 1 unit. Area is 1 unit. Now you start decreasing b, keeping the area conserved. So what will happen? Suppose I decrease b, b को मैं मान लो बहुत छोटा कर दूं, तो a की वैल्यू क्या हो जाएगी? It will become very large, so that the area remains 1. So b will become very small and a will become very large, but still area is 1. So इसी चीज को हम ट्रांसफॉर्म कर देते हैं and we denote it like this. This is sometimes पहले हम ऐसे डिनोट करते हैं एक्चुअली, अगर आपने किसी बुक में देखा हो. It is denoted like this. देखा है?
Yes, sir.
It is
Quantum mechanics.
so this is also a is equal to 1 and this is also a is equal to 1. Area is same, but इतना पेंटिंग बनाने से अच्छा है, what we do is we just put it like this. Okay, these two things are same. And what is its location? X naught. X naught is its location. Here also location is x naught, and this is also a function, and we represent it like delta x minus x naught. The meaning is that its location is at x naught. The location is at x naught. So this is known as Dirac delta function. So that's why when by area under the curve is 1. So when I take delta x minus x naught dx, this is the area under the curve. So when I have to include this, but अगर मैं यहाँ का area निकालूंगा तो it should be 0. This should come in between. So that's why I take limit minus infinity to plus infinity. That means 100% it is going to come in between. बात समझ आई? This is area under the curve. So this function is known as Dirac delta function. And if I take minus infinity to plus infinity fx delta of x minus x naught dx, then what is going to happen? So because the value of this function is always 0 except at x is equal to x naught. So जैसे ही x is equal to x naught लोगे, ये constant बन के बाहर निकल जाएगा और इसकी वैल्यू 1 हो जाएगी. So इसका आंसर आ जाएगा, the answer will become fx naught. So this was little bit about Dirac delta function that I have used. Okay, ठीक है ना? Okay, so I'll stop here, and only this much you do for Fourier series. Revise everything whatever I have done. Just make yourself comfortable with the integrations. Don't do any mistake while doing integration, and see the properties also. और a naught के बारे में एक final चीज मैं बताना चाहूंगा कि when we write, suppose fx is equal to a naught by 2 plus summation this is there. So we write a naught as in the range, suppose the range is given minus pi to pi or minus L to L, whatever you want to take. So the value of a naught is given as 1 by pi integral minus pi to pi fx dx. Am I right? This is the formula.
Yes, sir.
Yes, sir.
And if I take average of fx, what is average of fx here? It will become minus pi to pi fx dx over integral dx minus pi to pi. यही तो होता है एवरेज की डेफिनेशन. एक क्वेश्चन TIFR में डायरेक्ट
Yes,
इसी पे
sir.
आता है, टू कैलकुलेट द एवरेज ऑफ अ फंक्शन. तो व्हाटएवर रेंज इज गिवन उसमें, so this will become integral minus pi to pi fx dx over 2 pi. Correct? And what was a naught? This over pi. So I can write average of fx is equal to, इसको मैं क्या लिख सकता हूँ बताओ भाई?
A naught by 2.
This is another way of seeing this. Okay, understood or not?
Yes, sir. Yes, sir.
तो कहीं भी देखना, अगर फंक्शन गिवन है इस तरीके से, मान लो यहाँ 0 है और यहाँ 1 है तो इसकी एवरेज वैल्यू इसके बीच में ही तो होगी, द एवरेज वैल्यू ऑफ द फंक्शन, एंड हियर इट इज सपोज माइनस पाई, 0 एंड पाई. Okay, so the a naught value can be related to average value. So I will stop here, and then we will take some next chapter. Okay, thank you.
Thank you, sir.
Thank you. Okay, so in today's class, after Fourier series, the continuation will be the Fourier transform. Fourier transformation. So if you remember, in Fourier series, the function has to be either periodic, or I told you it should be piecewise periodic. Then only we can write the Fourier series for that function. That means then only we can decompose that function into sine and cosine uh, in all of the possible harmonics. Okay, but Fourier transformation can be written for non-periodic functions also. So we can write Fourier transformation for non-periodic functions also. Okay, so this is the first point, that we can write the Fourier transformation for non-periodic functions also. And here what we are going to do is, we are going to write a function into a different space. I mean, like, suppose I have a function ht. Okay, this is a function of, suppose, time. Mathematically it can be anything, but let us talk about physics little bit. So suppose this is the function of time, so we can convert this into another space, and that is Fourier space. Okay, and this is written like this. The notation will have lot of meaning, you will understand. Small h and capital H means this is some other function, and this is some other function. So that's why small and capital. Okay, because the suppose this is a sinusoidal function. That means the function made up of sine and cosine, and this is, suppose, Dirac delta function. So both are different functions, so that's why I am using this notation. So suppose, going from here to here, I call this as a Fourier transformation. Then coming back from here to here will be inverse Fourier transformation. Okay, so this is a Fourier transformation, and this is inverse Fourier transformation. Inverse Fourier transformation. Okay, so the why we do transformations? So we do transformation because we have certain advantages in that form. So suppose हमने ht को कैपिटल HF में कन्वर्ट कर दिया, और इस फॉर्म में there are some advantages, so we will just utilize those advantages, and then we can come back in again in original form. So there is always a possibility, because you have inverse Fourier transformation also. Okay, now this is a very important analysis tool. Okay, Fourier transformation is very important analysis tool. We can analyze the functions. Okay, and next thing is solution of partial differential equations. Okay, so many partial differential equations, for example, in electromagnetic theory, etc., we use this Fourier transformation. And next thing is that, suppose we have ht also, and we have hf also. So these two forms are available. So simultaneous visualization this gives lot of insight. Okay, visualization, this gives lot of insight, because you can visualize the function in real domain also. Real means original, and the Fourier domain also. So that gives you lot of insight lot of applications are there for this. That means you have original function, so you plot the original function, then you have the function in the Fourier space, and simultaneously you can visualize what is happening to this in time domain and what is happening to the same thing in frequency domain. So you can simultaneously visualize and understand the function. Okay, so this is what I mean. Simultaneous visualization of function is very important, and this gives lot of insight. Okay, now if I move further, suppose you have a function ht. So its Fourier transformation is suppose this notation represents the Fourier transformation. This is suppose hf. So this transformation ht to hf will have, if you see this, this will have real part as well as imaginary part. So this is the Fourier space, this is the real space. So the Fourier space will have, this is a complex function, so obviously it will have a real part as well as the imaginary part, and this will be known as the magnitude of this function, and this will be the real part, and this will be the imaginary part. Real part and imaginary part of the function. Sometimes even the angle phase will be very important. So we can define phase also as tan inverse IF over RF. This will be the phase. Okay. So now I will give the formula how to convert a function into its Fourier transformation. So can I erase this? This is note down, just simple things are there.
Yes, sir.
Okay. So one question from this Fourier transform. I told you Fourier series, Fourier transform, Laplace transform. These three topics will give you 2 questions. Okay. So now there are many formulas. You will see and get confused uh, that which formula is correct. The answer is every formula is correct for Fourier transformation. Different people use different definitions. All of the definitions are correct. It is not like only this definition will be correct. But I am using the most standard definition, and for this I am following a book, Brigham. Okay, this I am following. This book is on Fourier transformation, Brigham. So for this also you can find out the soft copies, but अभी तो जितना आपको required है, see it from here. So now please see. Now I told you that I can convert this ht function into h of f. So how I will do this? I will use a definition to convert. There should be proper definition. Then only you can come back. You can take inverse Fourier transformation. So that definition is hf is equal to integral ht e to the power minus, and I will be using j here as under root minus 1. So ht integral minus j 2 pi ft and dt, limit from minus infinity to plus infinity. This will be the definition that I am going to use, and please see when the integration will be done in dt, I mean t. When the limits are put in t, t will be gone. What will remain? F will remain. Okay, when you put the limits in t, t will be obviously gone, and you will get the value in f. And when you write h of t here, it will become minus infinity to plus infinity h of f e to the power j 2 pi ft and df. So these if we call Fourier transform, then this will be inverse Fourier transform. So if this is the Fourier transform, this is the inverse Fourier transform. So that means the definitions are related to integrals. Yes, the definitions are related to integrals. So please see these definitions clearly. This will be the formula that I will be using. So this is from going from time domain to frequency domain. It was like this. And if I write the other one, going from x space to k space, that means position space to k space, then what will be the formula? That also we should write. So if I write this as suppose fx and going there, suppose I write it by capital Fk. So this is the real space, this is the Fourier space. So f of k will be given by integral minus infinity to plus infinity fx. So here we had negative sign, and in this I will take j of kx and dx. So if I will do the integral in x, so here it is plus. Integral in x, then the x will not appear in the final result, only k will appear, because x में तो हम limits put कर देंगे. And if I take the inverse Fourier, then what will happen? So it will become f of x is equal to, now you can tell, f of x is equal to integral
Integration f of k e to the power minus iota kx dk.
minus infinity to plus infinity f of k and e to the power minus
Minus.
j kx and dk. Please see this. This is what. और इसमें चैप्टर में अभी जो क्वेश्चंस पूछे जाते हैं वो बहुत डिफिकल्ट नहीं पूछे जाते हैं. वी कैन मैनेज. सो जस्ट आप फॉर्मूला सीख के थोड़े एप्लीकेशन सीख लोगे, यू विल बी एबल टू डू इट. So this is the complete definition. Okay. So now any doubt up to this?
Sir,
Hmm.
sir,
Hmm.
so this h of t and f of x function, that variable inside change over, sir.
हाँ.
Okay.
So like if you write e to the power j kx minus omega t, na, you write it like this,
Yes, sir.
the wave propagation. So if it is a wave propagating in positive x direction, you write it like this. So that means the sign of omega and sign of k are opposite. These all things are conventional, okay? Like this definition is given in the question when they ask in exam. Either it is given or they will ask a question in which definition will not matter. So you just don't worry about this. You just learn. So I am taking from here, omega is equal to 2 pi f. Na? Omega is equal to 2 pi f. So I am taking the definition from here, this one for time and this one for space. Correct? So that's why they are having different signs. Okay?
Okay, sir. Thanks.
So now you should not get confused. So I will give other definitions also. It should be there in your copy so that आपको ऐसा ना हो कि ये क्या है, पता होना चाहिए. So if I write for Fourier transformation of ht and h omega, if I write h of omega is equal to minus infinity to plus infinity ht uh, e to the power minus j omega t dt, and let me put as a coefficient, let me put a1, and I write ht is equal to a2 integral minus infinity to plus infinity h of omega e to the power j omega t and d omega. Suppose this is the Fourier transformation, this is the inverse Fourier transformation, correct? Now, the possible values of a1, a2 may be 1. The values that people take, a1, a2, according to their own conventions, huh? So a1 may be 1 by 2 pi and a2 may be 1. This may be other definition. In other definition, a1 may be 1 and a2 may be 1 by 2 pi. And in some books you will see the definition in which both are a1 and a2 are 1 by under root 2 pi. So that's why the first thing to understand to read Fourier transformation is there are other different definitions which people take in their own domain, in their for their own conventions. Like people using this in electromagnetics, they use different definition, and people using in mathematics, they use different definitions. So yes, you don't worry about that. Okay, just you know this, that all definitions are correct and there are many definitions possible. Is that okay?
Yes, sir.
So that's why I have put this, so that you will not get confused. You will understand that there are many definitions possible. Now, ये नोट कर लिया सबने ना? Everybody has noted it down? Yes?
Yes, sir.
Okay. So now, there will be two integrals that I will be using very frequently. Huh? And that I should tell you. पहले ही बता देता हूँ. I will be using these integrals. Number one, minus infinity to plus infinity e to the power minus j2 pi f minus f0 t and dt will be delta function f minus f0. And second, integral minus infinity to plus infinity e to the power minus j 2 pi f plus f naught t and dt will give you delta function f plus f naught. Please see this carefully. So there are two different frequencies here, f and f naught. So f is that your normal frequency which I was discussing. So this is your Fourier frequency. Fourier frequency. And suppose the signal in which that frequency is coming is f naught. मान लो आप कोई फील्ड ले लो कि E is equal to E naught 2 pi f naught t, your function. So that is your signal frequency. That is your signal. So don't get confused. There are two types of frequencies. F is your Fourier frequency, which you are taking to transform it, and another one is signal frequency. And let us plot these two, how the plot will look like. So this is 0, this is axis, and f is, this is f axis, f is equal to f naught is a delta function. Similarly this is 0, this is f, and f is equal to minus f naught is again a delta function. So I told you that the location of the delta function will be, you can get by putting this inside equal to 0. That will be the location of the delta function. So in for this Fourier transformation also, the delta function will be very, very important. So you must know the properties that I have told you about the delta function. Correct? Now let me start by some. So now actually this is all about Fourier transformation. Then we have to learn some properties also. But डेफिनेशन पॉइंट ऑफ व्यू से अभी तक जो क्वेश्चंस आए हैं उसके पॉइंट ऑफ व्यू से अगर इतनी नॉलेज है तो यू विल बी एबल टू मैनेज. ओके, नाउ लेट अस सी अ वेरी वेरी सिंपल फंक्शन. सपोज वी हैव अ फंक्शन like this, h of t is equal to k. So how this plot will look? This is t and this is ht and this is k. From minus infinity to plus infinity, it will look like this. You agree with this? A constant function. A constant function. So in real domain, it looks like this. Now I want to see the picture, what will happen in the Fourier domain. So h of f is equal to minus infinity to plus infinity k e to the power minus j 2 pi ft and dt. देखो जरा सही लिखा है? Is this so correct? The definition I have applied. So what will be the hf? It will be k integral minus infinity to plus infinity e to the power minus j 2 pi f minus 0 t dt. Is this okay?
Okay.
So hf will become k delta of f minus 0, or sometimes we write it like this, k delta f. So we will plot this also. The location of the delta function is at origin. This is the delta function. And we write k here. The meaning is not its height is k, but its area is k. याद आया? पहले area क्या होता था? 1. If this was not multiplied, what was the area under the Dirac delta function? 1. But now when this k is multiplied, that means the area is k. This much you have to understand. And this is your axis of HF. So please see how the picture changes. The photo in real space looks like this, and the photo in Fourier space look like this. So this requires so many points to tell that the function is same everywhere. But this only requires one point. At one point you tell the function is there, and other points it is just absent. So the photo changes. So ये जो आपका पूरा image processing होता है, जिसमें आप पिक्चर को एडिट कर लेते हो, बदल लेते हो, आजकल तो बहुत सारे एप्स भी होते हैं. So all those image processing is related to Fourier transformation. The data from real space is carried out to Fourier space. There the processing is done and back to real space, because you want to see your picture, so it should be in real space. So image processing is very advanced and very important research area. So ये भी एक प्रीवियस ईयर क्वेश्चन है. सोच रहे हो कितना आसान है? जस्ट के दिया हुआ. So this photo is there, and then ऐसी 4 photos हैं, which is the Fourier transformation. So you had to select that. This is the Fourier transformation. Now let me take another one. So this time I am taking a sinusoidal function. That means sine or cosine, both I will take one by one. So पहले sine लेता हूँ. A sine 2 pi f naught t. this is the signal. Suppose this is some signal. And what is f naught? Can anybody tell?
Signal frequency.
Very good. This is signal frequency, not Fourier frequency, ना? अभी तो Fourier की कोई बात ही नहीं है. This is the signal frequency. So I will tell you how to calculate Fourier of this. HF will be given by integral minus infinity to plus infinity a sine of 2 pi f naught t e to the power j 2 pi f t and minus and dt. Please see this. Everybody knows this step?
Yes, sir.
So this will be equal to a, I can take outside, and integral minus infinity to plus infinity e to the power j 2 pi f naught t minus e to the power minus j 2 pi f naught t by 2j into e to the power minus j 2 pi ft and dt. So this will become a by 2j and integral minus infinity to plus infinity. What will happen when they will be multiplied? E to the power minus j 2 pi f minus f naught t dt. And what will happen if this will be multiplied? Minus integral minus infinity to plus infinity e to the power minus j 2 pi f plus f naught t and dt. Please see this. Is that okay?
Okay, sir.
And finally you will see it will become a by 2j delta function f minus f naught minus delta function f plus f naught bracket close. करेक्ट. सो वो जो फॉर्मूला पहले बता दिया मैंने वो देख रहे हो ना कितने काम का है.
Yes, sir.
और उसकी अंडरस्टैंडिंग भी आप कर सकते हो कि जैसे ये साइनोसॉइडल फंक्शंस हैं तो वो तो प्लस माइनस दोनों डोमेन में जाते रहते हैं. जितना प्लस जाते हैं उतना ही माइनस जाते हैं. तो इसलिए उसका इंटीग्रल वैसे तो जीरो है लेकिन जब f इज इक्वल टू एफ नॉट हो जाएगा तो ये क्या बन जाएगा 1. तब इसका इंटीग्रल इनफाइनाइट आ जाएगा. तो हमें ऐसा फंक्शन चाहिए था जो हमेशा जीरो रहे जस्ट f इज इक्वल टू एफ नॉट पे क्या हो जाए इनफाइनाइट हो जाए. सो दैट्स व्हाई डिराक डेल्टा फंक्शन. नाउ this will become, if you write it properly, this will become j into a by 2 into delta function f plus f naught minus delta function f minus f naught and this. And if I plot this, taking this as imaginary axis and this as f, if I plot it, what I will get? Tell me. So delta of f minus f naught will be here. This will be minus f naught frequency. And this side f is equal to f naught is also there like this. So this is f is equal to f naught. This is 0, this is f, and this is h of f. Please see this. So देखो real space में the photo of sine was like this. Correct? This was the photo. This is ht. This is t. And when this whole will become pi, then this value. This value can be calculated by putting 2 pi f naught t is equal to pi. Because here pi should be there, na? Pi पे 0 होता है, so it will cancel. So this value is 1 upon 2 f naught. So this frequency is 1 upon 2f0. So this photo is converted to this photo in Fourier space. And this is 5-mark question previous year. That they gave it like this, that a signal is sinusoidal and it is having amplitude A and frequency f0. Okay, and this this signal is converted to Fourier domain. Fourier transformation has been done, and the sampling frequency is taken 1 by, I mean, this 1 by 2f0. So अगर 1 by 2f0 होगा तो ही you will get this ना minus 1 by 2f0 like this. This is the time of sampling. नहीं तो अगर इससे कम करोगे तो ये पूरा सिग्नल आपको मिलेगा नहीं. You will not get this signal. इसलिए आपको कम से कम इतने का सैम्पलिंग करना पड़ेगा, इस डेटा का ट्रांसफॉर्मेशन करना पड़ेगा. Okay, so this is being done. And what is the transformed waveform? ऐसे करके, what is the transformed waveform? So how it looks like? So there will be 4 figures given, and please see, one very important thing is that this is odd function. This is odd function. So you have got the Fourier transformation also as odd function. This is also symmetric about y is equal to x axis. देखो, अगर ऐसी एक्सिस बनाओ, so जैसा इधर दिख रहा है वैसा इधर भी दिख रहा है. Yes or no? So if a function is odd, then its Fourier transformation is also odd. And one more thing, if the function is odd, then its Fourier transformation is imaginary. If the function is odd, and you can see that you got the Fourier transformation as imaginary when the function is odd. And if the function is real and odd, मतलब real भी है and odd भी है. And if the function is real and even, then the Fourier transformation will also be real. Correct? Any doubt in this?
सर एफ नोट का ग्राफ नीचे क्यों ड्रॉ करा है?
क्योंकि यहाँ पे माइनस साइन है. इसको कैसे
ओके
एकोमोडेट करोगे भाई? जैसे कोई चीज मान लो 1 यूनिट ऊपर है तो यहाँ प्लस है, और यही माइनस आ गया तो मतलब नीचे है.
1 डाउन.
तो मतलब इसमें और इसमें कैसे फर्क लेके आओगे बताओ? एक तो पोजीशन वाइज है, यहां से देख लेते हो, और एक आगे मैग्नीट्यूड वाइज. और ऐसे करके बना देते हैं a/2. इसका मतलब होता है इसका एरिया a/2. आई टोल्ड यू, इसकी हाइट तो इनफाइनाइट है, बट द एरिया इज a/2. ओके प्रियंका, इट्स ओके.
यस सर.
एनी अदर थिंग? This is very important. Please note down this property. Now, let me tell you, a Fourier transformation of ht is equal to a cos 2 pi f naught t. And what is this function? Real and even. And you know in advance what type of transformation you are going to get. कोई बता सकता है?
रियल.
Real and even. So पहले वाला imaginary and odd था. Now this one will be real and even. So let us see. So hf this time will become, अब मैं थोड़ा डायरेक्ट लिख रहा हूँ, आप जरा ध्यान से देखना. A will be outside integral minus infinity to plus infinity, and it will be e to the power j 2 pi f naught t plus minus j 2 pi f naught t over 2 into e to the power j 2 pi ft and dt.
सर माइनस जे आएगा सर.
यहाँ पे
Yes, sir.
ठीक है. And this will become a, and now when this will be multiplied, it will become a by 2 integral minus infinity to plus infinity e to the power minus j 2 pi f minus f naught t plus plus minus infinity to plus infinity e to the power minus j 2 pi into f plus f naught t and dt, and this will be equal to a by 2 delta of f minus f naught plus delta of f plus f naught bracket close. Please see so that all steps are clear. And now if you see the plot, so the real function will be like this, the cosine function. It will look like this, the cosine, yes, and its transformation will look like this. So this was real even, this is a real even. So this is also symmetric about y-axis, this is also symmetric about y-axis. You can see that this is the y-axis. Okay, we don't write here just not to confuse you. This is just x-axis, but we are taking frequency on this, and this is y-axis, we are taking hf on this. So the previous one is also a previous year question. In many forms they have asked that. This is also just the photo was drawn and they asked which one of the is the Fourier transformation. So even if you don't know how to do the Fourier, if you know the property, you can just take. Tell me, ये समझ आ रहा है भाई सबको?
Yes, sir.
So this also you can prepare with class itself. सारी चीजें आपको जितने टाइप के क्वेश्चन है वो मैं सारे करा दूंगा. So आप क्लास में ही साथ में ही प्रिपेयर कर लो, बाद के लिए उसको मत छोड़ना. Okay, then we will discuss it tomorrow. Okay, thank you.
Thank you,
Thank you,
sir.
sir.
Thank you.
Thank you, sir.
Thank you so much, sir.